Hello, so today we are going to do this problem called Pacific Atlantic Water Flow. So part of Leetcode August Daily Challenge. So we have an n by n rectangular island that borders the Pacific Ocean from the top and the left side, and borders the Atlantic Ocean from the right and the bottom side, right? And what we want is to basically the matrix also has these values which are called heights. So 5 represents height 5, 3 represents height 3, which represent the height above sea level. And what we want is basically water can flow from a cell if the neighboring cell is less than or equal to it. So 5 can flow to 3, 3 can flow to 3 can flow to, because it's smaller or equal to it, and 3 can flow to 2, 2 can flow to 2, but 3 cannot flow to 4 because it's bigger than it, so this is not possible. So that's the idea. So neighbors are all those that have height, all those that are to the left, right, top or bottom of a cell, but have values less than or equal to the current cell value. So that's the idea. And the goal of what we want to return is a result array such that has all the coordinates of all the cells where water can flow from that cell to both Pacific Ocean and the Atlantic Ocean, right? So if basically Pacific Ocean, both the Pacific Ocean and the Atlantic Oceans are reachable from a cell, with the definition of reachable being this here, with this, with these top, bottom, left, right being the directions, then we consider those, we return these in the result, right? Now let's take a look at the example here. So we have this matrix, and what are the values that, let's take a couple of examples. So 0, 4, if we take the 0th row and then take 0, 1, 2, 3, 4, so 5 here, it can flow to the Atlantic Ocean just by going left, right, going right, and then it can flow here by going top. If we take a look at 1, 3, so 1, 3, 4 here, well, it can flow to the top here to Pacific Ocean because 3 is smaller, so we can go there, and then from there we go here. We reach here. Once you reach the boundaries, basically, you can consider yourself. You can consider you have reached the ocean, because once you are in one of these boundary cells, let's say that either the top row, left row, or rightmost row or bottom row, rightmost column or bottom row, then yeah, you can consider yourself reached these. Basically, there is no restriction into moving from here to here, or here to here, or here to here, or bottom to the Atlantic Ocean. Yeah, so let's take a look at the other examples here. So 1, 3, we said you can go to the Pacific Ocean this way, and then because 4 is equal to 4, you can also go this way. So you can go to both, so we need to return it. So we need to return these two. For 1, 4, this 4 here, we can go this way, and then we can't go to 5 because 5 is bigger, but we can go to 4 because it's equal, and then to 3, and then we reach it. So 1, 4 is also a valid solution. 2, 2, for example, just to make sure we understand this. So 2, 2, 0, 1, 2, that's 5 here. Well, we can go, this is smaller, so we can go there, we can go here, and then we reach the Pacific Ocean. We can go here, and we reach Atlantic Ocean. So you get the idea, and we return it for all of them. So that's the problem we are dealing with here. Now let's see how we can solve it. Okay, so let's see how we can solve it. So this is the matrix that we get. Now, one thing to note is that all the cells here and here and here and here are immediately reachable by the Atlantic. This one is immediately reachable by the Atlantic Ocean, and this one is once you get here, you can reach the Pacific Ocean. Once you get here, you can reach the Pacific Ocean, and once you get here, you can reach the Atlantic Ocean. So that's the main idea. So now, knowing that, we can just think, okay, let's reverse the process, right? So the problem asks us to start from the cells and try to go to the Pacific Ocean using the rule that the neighbor, the value in the neighbor, the height in the neighbor has to be smaller or equal to the height in the current cell, right? So how about we reverse it? Instead of doing this, well, let's just start from the cells that we know are reachable. So those that are in the edges, and then just try to go to all the cells, and all the cells that we can reach, those are the cells that can go to Pacific Ocean or Atlantic Ocean, right? So the idea is to start from, for each, so what we want is to be reachable from both, right? So what we want is reachable from the boundaries of both Pacific Ocean and Atlantic Ocean, right? But we can do this separately, right? We don't have to do it for both at the same time. So what we can do is first have those, maybe have a visited from the Pacific Ocean and have visited from the Atlantic Ocean. Basically have all the cells that we can visit from the Pacific Ocean, which are all the cells that we can visit when we start from these, and all those that are visited when we start from these, because once you reach these, you can just go to the, we can just go here and go to the Pacific Ocean or here, right? So we do that for the Pacific Ocean and we get the set, and then we do the same for the Atlantic Ocean. So we just start from this column and from this row, and we see all those that are reachable. And then we put these in this, and then our solution would be just the union of these two sets. So we can do it separately. So that's the second idea. So the first idea is to start from the boundary rows and columns, and then the second idea is to just do it separately and union everything together. Now the question becomes, how do we determine that we can go from here to here, right? If we started from the cell and we need to know if we can reach the boundary row or column, we can just check this formula, right? That 4 is the current cell needs to be bigger than the 3. But if we want the reverse, right? We want to go from here to here, we need to reverse this relation, we need to do smaller. Right? Because this is actually we are starting from the potential neighbors, right? So what we want to check instead is that the current is smaller or equal to the neighbor, right? Because the original problem says we want to go from here and try to go here, but we are starting from where we need to arrive, and so to trace it back, we need to reverse the relation, right? Because if, let's say A is smaller than B, right? And that's if we are looking at B, but if we are looking at A, we need to check smaller, right? So that's kind of the way we are reversing it. I hope that makes sense. And so that's pretty much all we need to understand here. So the third observation here we are doing is we are going to start from boundaries and traverse with the rule that current smaller than the neighbor, because we are actually starting from these boundaries and looking for the cells that would have reached the boundaries, right? Okay, so what's the process is going to be? So we are going to use definitely DFS here. You could use BFS as well, but the general idea is we are going to do DFS and start from the boundary cells. So we'll do DFS and start from the boundary cells. Let's take an example here just for the Pacific Ocean where we are filling this visited set. So we are going to start from these. We will start from each of these points and do DFS and try to see what are all the cells that we can reach using this formula here, using this this condition, but the other condition is that the neighbors are only left, right, top, bottom. And so here our neighbors, can we go to 3? So can we go to 3 here? 1 is smaller than 3. So we can actually go there, right? Because the real problem says if 1 is bigger, 3 is bigger, then we can go here, right? So that's why we reverse it. And so that automatically means that this position here, we add it to visited, right? Because it's reachable. So we would have, what is this? This is 1 and this is 0. So 1, 0 is going to be added to the visited set of Pacific Ocean. And then we'll go, the neighbors are, can we go to 2? Well, 3 is bigger than 2, so we can't go there. Can we go here? No, we can't go there, so because it's bigger. And so we stop for 1 here. And for 2, we try to go here. We can because it's equal. And so this one is reachable, so we will add, this is 1, 1, so we'll add 1, 1 to the visited set of Pacific Ocean. And then can we go left to 3? 3 is already visited anyway, but also it's is the current is 2 smaller? Yes, so we can go to 3, but 3 is already visited, so we don't go there. Is this visited? We can go. Can we go to this 3? Yes. Is it visited? No. And so we can go there. So we add this. So this is 2, 1. So we add, or 1, 2. So we add that to the visited set, and we keep doing this until the end. And then we do the same DFS traversal for this side here. And we do the same thing that we did for the row. And then once we do that, so we will fill all the visited Pacific Ocean. The second step is to do it for the Atlantic Ocean visited set, and so we'll go here, right? And then we will say, okay, 5 is, can we go to 3? 5 is bigger than 3, so we can't go there. Can we go to 4? Yes. 4 is, 5 is, no, we can't actually go to 4. And so we can go anywhere here. If we start from, then we start from 4. Can we go left? Yes, because 4 is equal. And so we add 4 to the visited set for the Atlantic Ocean. And 4 is 0, 1, 2, 3. So 0, 1, it's 1, 3. Right, so we add that 1, 3 to the Pacific Ocean here. And then can we go to 3 here? We can't because 4 is not smaller than 3. Can we go here? No, we can't. Can we go here? No, we can't, so we stop. Now we go to 1. Can we go to 3? Yes, because it's 1 is smaller. And so we add 3 to the visited set for the Atlantic Ocean, so it's 2, 3. And then at the end we will have all of these visited set here, visited element here, and all of these visited here, and we take the intersection basically. And why do we take the intersection? Because the intersection means we were able to reach that cell from both the boundaries for the Pacific Ocean and the boundaries of the Atlantic Ocean, so which means that it's reachable from both. And yeah, that's pretty much it actually. Yeah, so let's implement this and make sure it passes test cases. Okay, so let's get started here. So we need the rows and columns, just the values. I'll just make this age so that it's easier to write. So this is the length, the number of rows, and the number of columns is h0. We are guaranteed that the height is smaller or equal, is bigger or equal to 1. And then we need to define both the visited things that we need. So we need 1 for the Pacific Ocean, and so this is a set, and we need 1 for the Atlantic Ocean. And then we'll do DFS. So we'll do our DFS here, but at the end, once we do the DFS, we want to return the intersection, right? Cells that are reachable by both. And we'll just get a set here. We'll convert it to a list because the problem wants a list. And now we will do first boundary rows. Start from boundary rows. And then we will start from boundary columns here. Okay, so for the rows, sorry, this is start from boundary columns, and this is start from boundary rows. So for the boundary columns, well, it's the first the top row and the bottom row, right? And so for the boundary columns, it's the first the leftmost row and the rightmost column, I mean. And so to do that, we'll need to go through I in the range of the size of rows, right? And what's so this is for the leftmost row, column, I mean. So we need to do the DFS on it and pass the coordinates I and j. For I changes, but for the leftmost column, j is always 0. And according to the problem here, the leftmost column is reachable by the Pacific Ocean, so we need to pass the visited set for the Pacific Ocean so that we fill that one. And for the rightmost column, we have I changes, right? But I changes, but the column the column is the same. It's the last one, and so to fill that one, we need to say it's columns -1. It's just n -1, right? And it's reachable by the Atlantic Ocean, not the Pacific Ocean. So we need to, any cell that is reachable from this column, we can say that it reaches the Atlantic Ocean. So that's why we pass the visited set for the Atlantic Ocean. Okay, and now we do it for the boundary column. So the boundary rows, top and bottom. So here we do a j in the range of columns, and we do DFS. So j changes, but for the top row, so this is here, top row, the row index is 0, right? So that's why we put here 0, and it's reachable by the Pacific Ocean, right? So we need to pass the visited set for the Pacific Ocean here. And then we do the same thing for bottom row. However, for the bottom row, j values change, right? But the row index is row -1, right? So that's why here we say rows -1, n -1, or m -1 essentially. And the bottom row is reachable by the Atlantic Ocean, right? So we want to pass the value visited set for the Atlantic Ocean instead, right? And now that we have all our DFSs that we need, right? We do 4 DFSs from each boundary. And now we need to write our DFS. So it needs ij, and it needs the visited set. And we know we want to visit. When we visit, we want to add to the visited set, right? That's why we can do this. And we want to go through the neighbors. I'll just create a function that gives us the left, right, top, bottom neighbors. And so we'll write it in a second. And we want to check that this neighbor is still within the boundaries, right? We don't want to go past the boundaries. So this needs to be rows, and this needs to be columns. And we don't want to visit something that we already visited, right? We did that in the overview, where when we reached 3 from here, because we already visited it from here, we don't go there, right? And so that's why here we need to check not in visited. And we need to check that this is valid cell to go to. And that's the initial condition, is that if you are coming from the cell to the boundary, you need to check that it's smaller or equal. But since we are doing it in the reverse, we need to check bigger or equal. So we need to check if the value, the height in the neighbor is bigger or equal, or actually let's write for ij. So we need the current cell, which is starts from the boundaries, needs to be smaller or equal to the neighbor. And the neighbor is actually the one that needs to be higher. That's the reverse of the initial one. And if this is valid, then we can go there. And so we can pass visited. Another thing we can do, just in case, for example, we are traversing here, but this one was already visited by the row, so we don't need to go there. So let's do a check here for ij in visited we want to return. And that way, since we are doing this check here, we don't need to do this check. Yeah, so that's pretty much it. We just need to go there. We don't need to return anything because we are already filling what we need in the visited sets. So let's run this. Yeah, we didn't define neighbors function, so let's just write it down. So that one should be pretty quick. It's just the top. So I+1 go to the top row, go to the bottom row, and here go to the right column, or go right, or go left, or go up, right? And that's pretty much it. So let's run this. And let's submit. And that passes test cases. Yeah, so that's pretty much it for this problem. The main idea here is we've got the problem text, but if we reverse it, the solution becomes easier, and so that's what we did here. Yeah, so that's pretty much it. Thanks for watching, and see you on the next one. Bye.